1, 2, 3, 4.
Lesson 6.4, Similarity and Measurement. All right, now we're going to expand upon the last lesson. We can use the proportionality, there's a $2 word, we can use the proportionality of corresponding sides of similar figures to solve problems. Because the sides are the corresponding sides can be set up in a proportion, we can find missing measurements of the sides of similar figures, as these first three examples are going to show you here. Now in the first example, we have two triangles. We have triangle STU is similar to triangle DEF. And we're going to try to find the measure of line segment DF, side DF, which I've got marked in the figure with an X. You can see it right here. So I've got two sides here in this triangle. I don't have the third side, but I won't need it. And I have one side here that's given, and of course that's the side I'm looking for, the one with the X. So what I'm going to do is I'm going to set up a proportion. Now, the FE side corresponds with UT. That's this side right here. So these two sides correspond right here. So I'm going to go this time little to big. I'm going to write the ratio of 36 to 45. Now you don't have to. You can go 45 to 36 as long as you're consistent with the next part of the proportion. Now I'm trying to find DF, right? DF, that's the first one to the last one. SU, that's the first one to the last one. SU is right down here. It's 35. So these two sides correspond. So again, I'm going to go little to big here. I'm going to go X to 35. I'm going to write X to 35. Now, I've got some two-digit numbers here that I'm going to have to multiply by. You can save yourself a little bit of time. If you notice here on the left side, this ratio can be simplified. I can divide top and bottom by 9. If I do that, that will give me 4 over 5 equals X over 35. Well, the numbers are a little bit smaller and the arithmetic should be easier. Two steps to solve this proportion, just like before. We're going to take the cross products. 4 times 35 is 140, and 5 times X is 5X. I'm going to divide both sides by the number times my variable, and X equals, let's see, it goes in 28 times. So X is 28, X is DF, so it says find DF. DF equals 28, and this is in millimeters, right there, because the measurements were in the units of millimeters. Very similar, no pun intended, an example, the next example given, KLMN is similar to PQRS. And again, the order of the letters is very important. It doesn't matter if it's alphabetical or not. Here, this was alphabetical, but this one was alphabetical, but it doesn't always have to be that way. In fact, down here in this example, they're not alphabetical. So that part doesn't matter. It's the correspondence. First letters, second letters, third letters, fourth letters, and so on. We're going to try to find SR. We have two what looks like rectangles or quadrilaterals, and we're going to, given that they're similar here, we're going to try to figure out what SR is. And again, I've got that marked with an X. So the side over here that I have is PS. PS goes from the first to the last. So first to the last here would be KN. That's this side. These two sides correspond. I'm going to go little to big this time. Little to big. I'm going to go 2 is the 3. That's this 2 and this 3. Not this 3, this one. And then the one that goes with SR is the last letter, then the third letter. So that would be KM, the last letter and the third letter. That's this guy right here. These two sides correspond. So I went 2 is the 3. Now I'm going to go 3 is the X. Little to big again. And I've got a nice little proportion here. I'm going to cross multiply. I get 2x equals 9. Divide both sides by 2. And I get 4 1/2 or 4.5. And so in this case, SR is equal to 4 1/2. And this is in centimeters. I kind of put my answer in the middle of the figure there because I'm running out of space. Now the next example is a little bit different looking. We actually have similar triangles here, but one triangle is kind of like contained in the other triangle. We got the little guy here on the end, and then we got the whole thing here. So we have that's good, PQR, and STR. Now in this case, we're trying to find QT, which is not a side of a triangle. the side of the triangle, the big triangle here, is QR. So I need to find part of it. So here's what I'm going to do. I'm going to call all of this QR here. I'm going to call that Y. All right, now I'm going to set up a ratio of my sides. Okay, I'm going to solve for Y, and once I have Y, I'm going to figure out what X is. So in this case, I have this side here, ST. ST, first two letters. So what corresponds? PQ, that's this side right here. These two sides correspond. So this time we'll go big to little. I'm going to go 25 is the 15. All right, now, down here, the big side here is the Y, that's QR. QR, the second and third letters. So TR, excuse me, the second and third letter. TR is right here. This is 18. So all of this to this. All of this to this here. So that's Y to 18. Y to 18. Now, just like I did with the first example, I noticed I could divide top and bottom by 5. So I'm going to write this as 5 over 3 equals Y over 18. Now I'm going to use my cross products. 5 times 18 is 90. 3 times Y is 3Y. Divide both sides by 3, and I'm going to put it over here. Y is equal to 30. Now that's not my answer. My answer, they're trying to find QT. That's this X that's right here. I know all of this, the whole side here, is now 30. Well, if this part here is 18 and all of this is 30, then this part must be 12, because 12 plus 18 is 30. So QT is equal to, and this is in meters, is equal to 12 meters. I had to get a little slick on that one because the measurement I was looking for was not an entire side, but part of a side. All right, one more example. And here's an example where you could see how using similar figures could help you to measure something that might be very difficult to measure otherwise. It says the shadow cast by a 4-foot-tall ostrich is 10 feet long. A giraffe standing nearby casts a shadow that is 25 feet long. How tall is the giraffe? Well, the idea here is that if you have these two animals here, you've got an ostrich here that's 4 feet tall, and it casts a shadow. Maybe the sun's up here somewhere, right? And it casts a shadow. Oops, didn't draw that very well. That is 10 feet long. Then you've got nearby a much taller animal, a giraffe. Let's say it looks like this. I'll extend my zoom around here. And the shadow here that's cast is much longer. In fact, the shadow cast is 25 feet long. Not drawn perfectly to scale. We want to know how tall the giraffe is. We'll call this G for the giraffe. Well, I have similar triangles. They're not the same size, but they're certainly the same shape because of the sun casting the shadow in a similar manner. So what I have here, I have the heights that correspond, I have the lengths of the shadow that correspond. So I'm going to write 4 is to G, this one is to this one, as 10 is to 25. As 10 is to 25. Now I can divide top and bottom by 5, and you don't have to, but it makes the numbers a little bit easier to work with. So if I divide top and bottom by 5, I get 2 over 5. Now I'm going to go through the steps. I'm going to cross multiply, excuse me. That's 20, and that's 2G. Divide both sides by 2, and I get G is equal to 10. So the giraffe, maybe it's just a young giraffe, is 10 feet tall. All right, these are very useful problems on the proficiency test, so make sure that you practice, practice, practice.